Hello everyone, today we are starting chapter 8 Sequence and Series. So first in 8.1 we have to define what is a sequence. A sequence is an ordered list of numbers. So you can say ordered list of numbers. Sequence can be of two types. It can be a finite sequence or it can be infinite sequence. Finite sequence means the number of terms are finite. Infinite sequence means the number of terms in the sequence are infinite. And we will always say this is the first term, second term. We never say zero term. So whenever we have to calculate the term of a sequence, we have to start with the first term. In the question number 1, it says find the first 6 terms. If I calculate the first term, how I can calculate the first term? Replace n with 1. So 2 into 1 plus 5, which is 7. The first term is 7. For the second term, replace n with 2. 4 plus 5 is 9. Third term, 2 times 3 plus 5. It's 11. And so on. You can calculate the remaining term yourself. Now look at the B part. F of n is equals to minus 3 to the power n minus 1. It's the same thing. F1 will be minus 3 to the power 1 minus 1. That's a 0. Something power 0. Or you can say any non-zero term power 0 is 1. Then f of 2 minus 3 to the power 1. It's minus. F of 3 minus 3 to the power 3 minus 1, 2, which is 9. And so on. We have to calculate for 6 terms. So remaining you can calculate yourself. Try it. In the next question we have to describe the pattern. So sequence terms are provided. We will see how they are forming. What is the general rule? In the last question, this is a rule given. We only substitute and get the answers, get the terms, but here terms are provided. We are writing the general term. General term is a term from which you can calculate any term, maybe direct 20th term, 100th term. Okay, you see what type of sequence it looks like. It's a 1, 8, 27 and all terms are negative. All terms are negative, so I am putting in negative sign. What is 8? 8 is a 2 power 3. What is 27? 3 power 3. 64, 4 power 3. 1, 1 power 3. It's every term power cube. So I can write the general term is negative n cube. Okay, look into this. 2, 0, 2, 6 and 12. First term is 0. I'm not saying this is a 0 term. I'm saying this is the first term. The value of first term is 0. And the next is 2. I can write 2 as a 2 into 1. 6. 6 can be written as a 3 into 2. Then 12. 4 into 3. So what are you observing the pattern? The pattern is a number multiplied with previous term. Number multiplied by previous term. Let's see for the first one also. 1 multiply 0. So number multiplied by the previous term. N multiplied by n minus 1. The general term. Okay. The next question is, here it says you are working in a grocery shop and are stacking apple in the shape of a square pyramid. So it's a form of pyramid. The apples are forming pyramid. Write a rule for the number of apples in each layer. How many apples are there in each layer? We have to define. So if you see, the first layer has only one apple. First is a one apple. Then two apples here and two apples are back. So next is a four apples. So next it will be a nine apples. So what you are observing, it is a square of a number. 1 square, 2 square, 3 square. The pattern will be n equals to n square. The value of n that we substitute is known as a domain. Domain is term, number of term. Number of term. If it is a first term, so domain is a 1. Range is the answer of that term. Value of that term. Value of that term. Okay. Next. Series and summation notation. Series means we are adding the term. If I say 1, 2, 3, 4 and so on, this is a sequence. Instead of this, if I add the terms 1 plus 2 plus 3 plus 4 and so on, this is a series. And we have to write the series now. The series can be finite or infinite. Summation notation. This is a sign of summation. It means you are adding the terms. So summation of a number. It may be 2i, 3i, 4i. I is moving continuously from 1 to any number. And it means if I open it, it looks like substitute n1, substitute n2, substitute n3. So it's like that. So the next term will be written but with plus sign. So this is how summation works. The last term is 3n. It's adding all the term up to n. This is a summation. And this notation is known as a sigma. Sigma notation is used to show the terms are in addition. Okay. Write each term or each series using the summation notation. So I write the summation. How many terms are there? 1, 2, 3. And I don't know what is the last term. There are 250. But if you observe the pattern, it is a multiple of 25. So 25 times I. Multiples. So I choose a multiple as a I. I starts from 1. And what is the last term? 250. How 25 become 250? By 10 multiplication. So the last term is 10 here. The summation I is equals to 1 to 10, 25i. Now see the next factor. If it is a 1, the denominator is a 2. If it is a 2, denominator, the denominator is a next term. So I can write, if n is at the top, denominator will be n plus 1. The next term here. What is that? It is the next term. And we can write the summation. Where the summation starts? Summation starts from 1. I is equals to 1. Where it ends? No, there is no end. It's a continuously going on. So I put a infinite sign. It's an infinite series. Next question says, find the sum. We have to find the sum of this. K is equals to 4 to 8. So substitute K as a 4. 3 plus 4 square. Now substitute here 5. 3 plus 5 square. 3 plus 6 square. 3 plus 7 square. 3 plus 8 square. Okay. Now substitute value. 4 4s are 16 plus 3 19. 25 plus 3 28. 36 plus 3 is 39. 52 and 67. If I add all terms, we'll get 205. Now we will write some formulas. Formulas to calculate the sum. If you have only single term without changing, so it's like only 2 is getting added. 2 plus 2 plus 2. Every time 2 is adding, but maybe 10 times. 10 times 2 is adding, 20 times 2 is adding. So when a constant term is adding, constant, I choose a 1. 1 is adding. How many times? N times. The answer will be 1 times n. If it is a 2 summation of 2, the answer will be 2 times n. Okay? If the terms are changing, like 1 plus 2, continuous natural numbers are there and we are adding the natural number up to n. I is equals to 1 to n. The formula is n plus 1 over 2. The next, if the terms are in a square and we are adding 1 square, 2 square, 3 square up to n square, the addition will be n plus 1, 2n plus 1 over 6. Then we are writing the formulas. Now look at this. We have solved this question here by writing its general term. General term was n square. And the question is saying how many apples are in the sack here. So total how many apples are there? To see how many layers are there. First layer, second, third, fourth, fifth, sixth and seventh. The last is a 7th layer. So that means we are adding up to 7 terms. So summation an was n square. So it's a summation of I square. I is from 1 to n. N is what? 7 here. Last term is 7. First to 7. Using this formula, n is a 7 in our case. 7 times 7 plus 1. 7 to the 14 plus 1. 15 over 6. So solve it. 7 times 8 times 15 over 6. 2 3s are 6. 2 4s are 8. 3 1s are 3. 3 5s are 50. 5 4s are 20. 20 into 7, 140. So I'm getting 140 apples here. So we are done with 8.1. I hope you understand. For watching.